Hello friends, welcome back to my channel Medicine of 101. Today we'll talk about ventricular arrhythmia. So before starting the video, let me tell you, I have already uploaded the video based on sinus arrhythmia. See, from here we'll get the sinus arrhythmia. Then I did talk about the what? Atrial arrhythmia. Then I already uploaded the video based on junctional arrhythmia. Okay, over here in terms of the epinodal arrhythmia, you can see also the nodal arrhythmia. Now, today we'll talk about the ventricular arrhythmia. Now, why do we develop the ventricular arrhythmia? What's the reason for it? The reason, basically, you can see one of the most common example for it. You can see the irritations within the ventricular myocardial cells. For example, if I say over here is the ventricular myocardial cells, you can see some irritations were within the ventricular myocardial cells. So, first the reason we can see over here the irritations. And ventricular myocardial cells. Why will see the irritations? Okay, why will see the irritations that I'll talk about. Let's talk about first the physiological conditions. What type of thing we'll see in terms of the ventricular myocardial cells. Then about why we'll see the development of the irritations and what type of the pathological findings for it. We'll talk about after after talking about the what physiological conditions. Okay. Now I'm just taking this piece of the myocardial cells, I'm just enlarging it over here. Okay, so let's take the piece of the myocardial cells over here. For examples, I'm just taking this the ventricular myocardial cells. What do you know? In terms of the ventricular myocardial cell, it is having the resting membrane potential, it is also having the threshold potential, right? So, as we know that we can take the resting membrane potentials, for example, for it minus 90 millivolt. Okay, let's write it properly. Minus 90 millivolt. And for example, the threshold potentials for it minus 70 millivolt. Minus 70 millivolt. Now, what do we know? Within the ventricles, there are the adjacent cells, adjacent myocardial cells. Okay, and for example, there is another adjacent myocardial cells of ventricular myocardial cells through the gap junctions, or you can see the electrical window. This will just pass the electrical impulse from this cell to the subsequent cells. For example, I'm just taking it over here. These are the cells, adjacent cells through which we'll see the transfer of the electrical impulse. Now try to understand what do we know in these cases. Whenever this is first this is, for example, that will be depolarized, and whenever we will see the depolarizations over here, we will see the influx of the sodium. So some amount of the sodium that will be sent from here to these cells. So whenever the sodium this cells, it will be sent where within this ventricular myocardial cells. At the time, the resting membrane potential that will be neutralized. What? Neutralized how much? For example, it will just touch the threshold potential. It is what is the threshold potential. Now, whenever it is just touching the threshold potential, try to understand. At first on the resting condition, it was in the what? Resting membrane potentials. Now it is just touching the from here the what? Threshold potential. And as we know that whenever it will just touch the threshold potential, at the time what the voltage sensitive sodium channel that will be opened, right? What the voltage sensitive sodium channel. So first we'll see the opening of the voltage sensitive sodium channel. So we'll see the influx of the sodium. So we'll see voltage sensitive sodium channel, right? Then whenever the sodium will come over here, it will cause the depolarizations within the ventricular myocardial cells. So whenever we see the depolarization, at the time we'll see maximum, it will go to this much level, for example. And whenever we'll see the depolarization is completed, okay, at that time for the short period we'll see, okay, there will be opening of what? Two channels, so calcium and potassium channel. I think you already know these things, right? So we'll see the opening of the what? Voltage sensitive calcium channel. For example, the calcium that will be opened, and we'll see what are the thing. There will be influx of the calcium over here, and we'll see also the opening of the potassium channel. We'll see also opening of the potassium channel, and we'll see the potassium, that we'll see the efflux. So we are getting over here that influx and influx and efflux of the two cations. So whenever we are getting, there will be no change in the potential difference, because some cations are coming and some cations are going from the cell. So as a result, in these cases we will not get any kind of the changes, like significant changes in these cases. As a result, we will get this type of thing. As we know, this is known as what? Plateau phase. This is known as plateau phase. Whenever we will get the plateau phase, at the time we will see after a certain time, okay, this calcium channel that will be blocked, but the potassium channel it will be working still. So as a result, we will see the potassium efflux will be continuing. So whenever the potassium efflux is continuing, as a result, the more amount of the cation that is going from the cell, as a result, we will see the repolarizations of the cell. We will get the repolarizations. So whenever we get the repolarizations at the time, we will see this thing that will come down again. So that will come down, and again we will see. Again we will see whatever thing, these cells after repolarizations, this will enter the resting conditions for a while. Why? Until the another sodium is coming over here from the adjacent cells, and until it is giving the electrical impulse from here to here. Okay, otherwise it will be not activated. So again, whenever the another for example, the some sodium cations are coming over here, and that is activating the rest, it is just taking the resting membrane potential to the threshold. Again we will see other depolarizations. So for example, okay, let's say extend some part from here. Okay, now try to understand from here. Again we will see what, from here to the threshold potentials. From the threshold potential we will see the depolarizations. After depolarizations we will get again the plateau phase for it. Then again we will get what, or repolarization. In these things we will get this type of patterns. Okay, so first we will get what, the whatever thing we will get first. Sodium cations are coming within these cells. This is taking the resting membrane potentials to the what, threshold potentials. Whenever it is just touching the threshold potential, at the time we are getting what, voltage sensitive sodium channels that is getting opened. Sodium is coming, so we are getting the what, major major depolarizations. After that, for a short period we will get the influx of the calcium and efflux of the potassium. That will represent the plateau phase over here. This is the plateau phase. Here we will not see any kind of the significant potential difference. Okay. Now this is a normal thing as we see. Now under pathological conditions, for example, we are getting the irritations within the what? We are getting the irritation within the myocardial cells. Now what could be the irritations? Now the causes may be over here. For example, we are getting the ischemia. We are developing the ischemia, or we are getting the physical injury within the cell. So whenever we get the ischemia within the cells, within the myocardial cells, to understand, as we know, in each cell there is a presence of what? Sodium, potassium, ATPase, right? In each cell there is a presence of what? Sodium, potassium, ATPase pump. By it will just actively throw 3 molecules of the sodium outside, and it will take 2 molecules of the potassium inside. Okay. Under normal circumstances, try to understand, whenever this pump is working, so sodium is thrown out and potassium is taken in. And whenever we are seeing the phenomenon of the depolarizations at the time, the outflow, we can see whatever the sodium is going out, the sodium that will be again taken away by this pump over here, by this process, and the potassium that will be thrown out. Now as a result we will see the balance, okay, during the depolarizations under resting conditions. That will be the balance in between the sodium and potassium. But whenever we see the ischemia, so try to understand, whenever we see the development of the ischemia, as a result we will get the ischemia, or you can say the hypoxia. You can say also the hypoxia, for example. So whenever we get the ischemia or the hypoxia, definitely the oxygen that will be less within the tissue, within the cells. So whenever the oxygen will be less, definitely the ATP production that will go down. So whenever the ATP production that will be less, as we know, the sodium, potassium, this pump is dependent on ATP. So whenever the ATP is less, this pump that will be dysfunctional. So as we will see, the ATP will be less, this pump that will be not activated further, that will not work further. As a result, see, when it is not able to function, so what kind of thing we'll see? Within the cells, the accumulations of the what? Within the cells we'll see the accumulations of the sodium. We'll see the sodium accumulations, the sodium that will be much more within these cells. Now whenever the sodium that will be much more within these cells, see, this sodium that will neutralize the resting membrane potential, this sodium that will neutralize this resting membrane potential, and maybe we'll see sometimes this the sodium that can also take the resting membrane potential up to the threshold. So try to understand from here that this sodium that will take the resting membrane potentials to the what? Threshold potential. So whenever it is just taking the resting membrane potential up to the threshold potential. At that time, we'll see the depolarizations. Now see, these depolarizations we are not getting for the physiological conditions. See, under normal circumstances, if we talk in terms of the depolarization within the ventricular myocardial cells, that is done by the what? Adjacent myocardial cells. Whenever they will just throw the sodium molecules of the cations, okay, within the subsequent cell, as a result, we will get the depolarizations. But here we are getting the depolarizations for what? For the dysfunctions, for developing the ischemia or hypoxia. Whenever the hypoxia is over here, oxygen is less, ATP is less, so definitely this pump will be not able to work. As a result, within the cells, there will be sodium trapping. There will be a trapping of the sodium. We can say accumulation of the sodium within the cell, that will be increased. So whenever it will be increased, definitely try to understand the accumulated sodium that will take the resting membrane potentials, okay, up to threshold. And whenever it will just reach up to threshold, at the time what? At the time we will see the spontaneous, we will see what? See the depolarizations. So whenever we get the depolarizations, okay, see. So this is a problem that can cause tachyarrhythmia. Can cause also the tachyarrhythmia from here. Okay. Now let's talk about another causes. So see, when you are talking this one, that the physical injury, if you get the physical injury within the cells, see, if you get the physical injury within the cell, try to understand from here, whenever you are getting the, or talking in terms of the physical injury, at the time the cell membrane that may be damaged. So whenever the cell membrane, for example, it is getting damaged, as we know, outside the cell, the concentration for the sodium and the calcium, that is more. Outside the cell, in the extracellular environment, concentration for the sodium and the calcium, that is more. So whenever we get the cell membrane damage over here, so there is a chances for the leaking in of these cations. So whenever we get the incoming of this cation or influx of this cation for developing the cell membrane damage, as a result, this thing they will just take what? They will just take this. Okay, let's show over here, then I think it will be better for you. It may take this, we'll see the fluctuations in the resting membrane potentials. So whenever the positive cations you are getting over here, whenever you are getting the cations, definitely they will try to neutralize the resting membrane potential. And maybe we can see this type of the waves in terms of these things, like they will take the resting membrane potential. Sometimes they can also touch the thresholds. So whenever they will just touch the threshold, try to understand from here. Okay, let me extend this part. Whenever it will just touch the threshold, at that time we will see again this phenomenon. This will be activated. Again we will see, as we see in terms of the depolarizations, again we will see the depolarization this way. Now try to understand from here. See, whenever we are getting the cell membrane damage, these things are coming. We are getting the fluctuations in between the resting membrane potential and the threshold potential. Sometimes the influx of this cation that can touch up to the threshold. Whenever threshold potential will be touched, at that time we will see the depolarizations process. Okay, so this is the another cause. Now sometimes if you see that in terms of the stress, okay, let me talk about these things part. For example, there are some persons who is having ischemia, or you can say in terms of the myocardial infarctions. Okay, if we see some patients of these types under stress, so if we see under stress, so what type of the hormone that will be released under stress? Definitely what? From the adrenal gland will see the releasing of the adrenaline hormone under stress, adrenaline. And whenever it will be released, try to understand, as we know, within the heart there is a presence of what? Beta 1 adrenergic receptors. See, we'll see within the heart there is a presence of what? Beta 1 adrenergic receptors. So whenever this hormone that will be released, they will come over and they will activate these receptors. And as we know, this is a G stimulatory protein. Okay, this is the what? G stimulatory. Whenever it will be activated, it will activate another enzyme. See, whenever under stress, let me repeat once again, under stress, what do you know? The adrenaline hormone that will be released, that will be released, that will come over here, that will activate the beta 1 adrenergic receptors. And as we know, the G stimulated protein that will activate what over here? We'll see. This will activate the adenylyl cyclase enzyme. That will activate the adenylyl cyclase. Whenever it will activate it will convert the what? ATP into cyclic AMP. ATP into cyclic AMP. So see, whenever we are getting the activation more and more, so more amount of the ATP that will be broken down into a cyclic AMP. So concentration of the cyclic AMP that will be more. So whenever we are getting the more amount of the cyclic AMP, we know that the cyclic AMP that will do what? That will activate another enzyme that is known as what? Protein kinase A. So whenever we get the activation of the protein kinase A, that will just do what? As you said, that in terms of the kinase, so that will do phosphorylation of extra calcium channels. That will do extra phosphorylation of extra calcium channels. So in these cases, for example, it will do, try to understand from here, it will do over here phosphorylation. Let me write it over here completely. Phosphorylation of extra calcium channels. As a result, we will see the more and more amount of the what? We will see here the more amount of calcium influx within these cells. So whenever we get the more amount of the calcium influx within the cells, definitely try to understand. Again, we will see the resting membrane potential that will touch easily the threshold potential. Again, we will get the depolarization. Okay. Now we will talk about the Ecg pattern. What type of Ecg we will get in these cases. Now, whenever we are talking in terms of the Ecg pattern, okay. At first, let's draw the normal Ecg. If we see in terms of the normal Ecg pattern, what type of thing we will get over here? Okay. The normal Ecg, if we write it over here, the normal Ecg pattern, we will get the what? P wave, is complex. We get again T wave, P wave, is complex, T wave, P wave, is complex. For example, T wave. Okay, this is the normal Ecg. Now, whenever we get this type of thing, for example, see, we are getting a cell over here. We are getting a cell over here. In this case, see these cells, these ventricular myocardial cells. Whenever you see this development of this ischemia or whatever the regions I have explained over here, if you see any kind of the things within these cells, these cells that will not wait for this bit coming. As we know what under normal circumstances, if you say for the physiological process, the bits or the electrical impulse that should come from the SC node to the AV node, from the AV node it will go within the bundle of Fitch, then it will go to the Purkinje fibers and it will reach up to the ventricular myocardial cells. It is the normal process, physiological. Now in these cases, as you know that we'll get this type of thing, we'll get the what? Loading of the cations within the cells, loading of the cation within the cells. As a result, these cells that will be not waiting, that will not wait for what? For the beat. So if we say over here, for development of the, okay, let's write it over here, cations, ions overloading, in terms of the what? Cations definitely, right? Here these cells that will be not waiting for the bits. When it will come, then again it will go depolarization, this type of thing we'll see. In these cases we will see this will go under the depolarizations and it will send the multiple vectors in the different directions. It will send the multiple vector in the different directions. And whenever it is sending the multiple vector in the different directions, what type of thing we are supposed to get? Circumstances if we talk, whenever we are talking in terms of the major ventricular depolarizations, we will get this one. This one will be the major ventricular depolarizations, right? Now maybe in these cases, whenever this cells is getting activated, maybe this is producing the vector that is going in these directions. For example, maybe it can go in these directions or the other directions. Here we are getting the foci, okay? This thing is known as foci. Okay, let me show this color only. I think it will be better. This is a cell. Okay, so we'll get the foci. Now this foci that will cause the that will cause the depolarizations, the pathologically, okay? So that will not follow the physiological process, that will cause the pathological depolarization. And what type of the Ecg pattern we will get over here, let's talk about those things. Now, okay, let's talk about those things first, then I think we'll talk about those. Let's draw this type of the thing first. Let's draw the pattern of this Ecg. What type of this Ecg we will get over here. Normally, what do we get? Okay, let's draw it more clearly. We'll get the P wave, Q complex. T wave will get, again we'll get P wave, Q complex, T wave. For example, in these cases, I am getting the Q complex. I'll explain, okay, don't worry. I'm getting the, for example, in this way, again we are getting the normal, tube. Again we are getting normal tube, QRS complex. Again we are getting tube. Again, for example, we are getting the tube. Now in this case, just try to understand. We are getting the the QRS complex in these directions. Again, we are getting the tube over here. Okay. Again, we are getting the tube, QRS complex, tube, for example. Okay. Now see, in the two cases, try to understand here. We are talking about the two ectopic foci. These are known as, from where we are getting the abnormal or pathological depolarizations. They are known as ectopic foci. So we are getting one ectopic foci. So ectopic foci. Here we are getting second ectopic foci. Okay. Now see, from the graph, okay, or you can say from the Ecg pattern, try to understand. For example, we are getting a, we are getting the pathological productions of the depolarizations from on portions over here. For example, on cells. Now the directions of the productions of the different kinds of the electrical vectors may be the different. Maybe it is along with the what? Along with this. For if we talk about the number 2 ectopic foci, the abnormal cells, the irritating cells that is producing the electrical vectors. For example, along with the what? Along with the major ventricular depolarizations. As a result, we are getting the the level. If we see over here, we will get the major ventricular depolarizations, but that will be much more stronger than the normal physiological conditions. But if we see over here, the directions of the producing of the vectors in terms of the major ventricular depolarizations, if we talk about this thing, we will get in the opposite directions. The vector that will go in the opposite direction. Here we will get in the two opposite directions. Okay, so we are getting the two ectopic foci. Now the second thing, let's draw another Ecg pattern. Okay, maybe I am drawing it over here. Okay, let's draw over here tube, QRS complex, tube, okay, QRS complex, tube. Now for example, okay, let's show you guys over here. Tube, again we'll get what the tube. Let's draw the tube, then I'm showing you the QRS complex. Okay, now see, for example, we are getting the QRS complex over here in this direction. So let's draw. Okay. Okay, then let's continue again. We are getting the normal. For example, the tube. Again, we are getting tube. Again, we are getting QRS complex tube. Now try to understand over here. Okay. Now see, we can talk about these things. It is abnormal productions of the QRS complex over here. We are getting, we definitely are getting that our tachyarrhythmia. We are getting the tachyarrhythmia. So from here, if we say from here, from on ectopic foci, we are getting multiple QR complex. Definitely we can say over here, we can say what? Maybe the beats that is more than 120, the beats per minute. That will be how much? More than 120. That can cause the what? That can develop also what? This is known as what? The ventricular tachyarrhythmia. Okay. Now in these cases we are getting, see, these things are known as what? Premature. Okay. Let's write the name of these things. This thing is known as ventricular premature beat. These beats we are getting over here, they are known as ventricular premature beat. This is also ventricular premature beat. Okay. Now we'll talk about the other things. Now let's talk about the ventricular flutter. What type of thing we'll get in terms of the ventricular flutter? So if we get the beats, for example, if we get the beats for here more than 200 beats per minute, if we get more than 200 beats per minute, then what type of thing we'll get over here? So let's draw these things over here. Okay. Now, if you draw in terms of the ventricular flutter, what type of thing we'll get? POF, QRS complex, again TOF you are getting, POF, QRS complex, and in these cases we'll get, when you are talking in terms of the ventricular flutter, see what are the thing we'll get over here. Okay, let's erase this part. Okay, now let's continue again. For example, we are getting over here, and again we are getting after some times, again we are getting the TOF, again we are getting the POF, QRS complex, TOF, okay, POF, QRS complex, for example. Okay, now here we are getting from on foci, from single foci, on ectopic foci, we are getting what? The productions of the abnormal depolarization, in terms, we can say major ventricular depolarizations. See here the QRS complex in this way. Now these things that will be known as what? Ventricular flutter. This thing is known as ventricular flutter. Ventricular flutter. Ventricular flutter. Now see, we'll talk about now the ventricular fibrillations. Now around, if we get beats, for example, if we get the beats per minute over here, 200, more than 200, at that time we will get this other thing. Now if we get the beats, if we get the beats, for example, the beats more than 350 beats per minute, if we get the beats, okay, more than 350, at that time what type of thing we'll see in this case, try to understand. If we get the beats more than 350 at the P, QRS complex, okay, TOF, again we'll get POF. Now when we are getting more than 350, at the time we'll get just normally a line over here. Now in these cases we'll get the beats per minute, that is more than 350, and this thing is known as what? Atrial fibrillation, the ventricular fibrillation. This thing is known as what? Ventricular fibrillation. And we can get, in terms of, when you are talking in terms of these things, the ventricular fibrillations, try to understand from here. Again we'll get the normal, for example. Okay, see. Now this will be the ventricular fibrillations. Whenever we get the ventricular fibrillations, we will get the multiple foci. For example, we are talking in terms of the 100 foci we are getting. Now from the 100 foci we will get what? The major ventricular depolarizations. We will get the ventricular depolarizations. Abnormal ventricular depolarizations. For example, we will get over here the 100 foci. So when you are talking in terms of the 100 foci at the time, see, when you will get the more amount of the depolarizations. So whenever we will get in terms of the, let's write it over here, I think then it will be easier for you to understand. Let's write it over here. Now see, in these cases, in terms of the, in terms of the ventricular fibrillations, in terms of the ventricular fibrillations we will get, there will be multiple foci. We will get the multiple foci from where we will get the productions of the depolarization, ventricular depolarizations. Now in these cases, the depolarizations will be so fast. In terms of the ventricular, in terms of the ventricular fibrillations, in terms of ventricular fibrillations, the depolarizations within the ventricle, that will be so fast that the mechanical activity that cannot follow the what? Electrical activity of the heart. So in terms of the here, in terms of ventricular fibrillations, the depolarizations within the ventricle will be so fast that the mechanical activity of the heart that cannot follow the electrical activity of the heart. So as a result, we will get over here the cardiac output that will be dropped dramatically. Okay, the cardiac output that will be dropped dramatically. As a result, we will see in the multiple places within the heart we will get the development of the what? Within the heart we will get the development of the ischemia. The cardiac output that will be dramatically fall over here. As a result, we will get the development of this. Whenever we will get the development of the ischemia within the multiple portions